Hi, in this video I'm going to show you how to solve a system of equations using the elimination method, and I'm also going to show you how to determine whether that solution or that system has one solution, zero solutions, or infinitely many solutions. So I'm going to start off with an example right here. And when we solve a system of equations using the elimination method, we have to have both equations in the same format. Now, many times we like to have that format be standard form, which I have these two equations in right now. They don't have to be in standard form, it's just one that we usually like to have them in. Now, what we do with elimination is we try to eliminate one of the variables by either adding the two equations together or subtracting the two equations. So we have to determine which variable would be easier to eliminate. And when I look at this, I notice that my x's are just opposites of each other. My y values, on the other hand, one's a -6 and one's a +4. So in this case, it's going to be easier to eliminate the x's, because if we were to just add those two together, and if all I focus on are the x values, if I add those two things together, I end up with 0, and that's what we want to do. We have eliminated the x's. So I'm going to add my two equations together, and when I add them together, like we said, the x's turn out to be 0x, and then the y's, I'll have -6y plus 4y, which puts me at -2y, and then 18 plus 12 is 30. So what I've done is I've taken those two equations, added them together, and now I have one equation that just has one variable in it. And if I have an equation with one variable in it, chances are really good I'll be able to solve that. And in this case, I can by dividing both sides by -2, and I find out that y equals -15. Now, to figure out what x is, we just need to take this y value and plug it back into one of those equations. And it does not matter which one we plug it back into. So I'm going to choose the first one for no particular reason. But I look at that and I go, well, I'm going to stay color coordinated. I have 3 times x, I don't know what x is, minus 6 times y, but my y value I now know is -15. And then it's going to equal 18. And this is an equation that has one variable, the x, that I can now solve for. So I'll work on solving this. I have 3x, and now this is going to be plus 90 equal to 18. If I subtract the 90 from both sides, I now have 3x equal to -72. And now all I have to do is divide both sides by 3 to find out that x equals -24. So I have solved my system of equations. I figured out that the y value is -15, the x value is -24. I could also put that in point format, so I could say my solution is -24, -15. So whether you want to display it as the x and y, like I have it boxed in, or as a point, either one is acceptable. Now in my next example, I'm going to do the same thing. I'm going to look to eliminate my x or my y. But in this case, I look at my x's and go, one's 2x and one's -3x. So if I add them together, that doesn't eliminate the x's. If I subtract them, that doesn't work either. So now I look to my y's and I go, oh, they're both positive 4y. And if they're both a positive 4y, if I want to make them go away, I want to eliminate the y's, I'm going to have to subtract this time. And I got to be careful on this because we have to subtract every single term. So I look at this and I go, I have 2x minus -3x. And if I take 2x minus a -3x, that's like 2x plus 3x, and I get 5x. Then we get the 4y minus 4y. Well, that's 0y. I'm not even going to write that down. Equals, and now I have 28 minus 18, which is 10. And I have my little equation here that I can solve. So if I divide both sides by 2, I just figured out, I don't want to divide by 2, I'm thinking ahead. I apologize for that. I want to divide both sides by 5, so I get a solution of 2. My x value equals 2. And now I plug it back into one of the equations. Now this time I'm going to look up there and I'm going to pick the green one, and the reason I'm going to pick the green one is because everything is positive in that one. So I have 2 times my x value, which is also 2, and then plus 4y equal to 28. Work on solving this equation. So I'm going to have 4 plus 4y equal to 28. I'm going to subtract 4 from both sides to get the y's all by themselves. And now I have y equal to 24. And then I'm going to finish it off by dividing both sides by 4. And I just figured out that y equals 6. So my solution to this system is x equals 2 and y equals 6. Or again, if you put it into point format, you're going to have the point 2, comma, 6. Either way, I don't care. X equals 2, y equals 6, or the point 2, comma, 6 would be fine for your solution. I have another one. We're going to solve this one by elimination as well. So this time I look at it, and I'm going to start with my x's and go, oh, I can eliminate my x's by adding. Because I noticed that one's a negative 5x, one's a positive 5x. If I add those two together, I get 0x. Right? Then I go to my y's. Well, 8y plus negative 8y, well, that's 0y. And then 10 plus negative 10, well, that's 0. So when it's really everything's done here, I have the left side of this equation says 0, the right side of this equation says 0, and you go, well, now what do? There's no variables. Well, here's what that means. This means that our two equations are really the same equation. If you ever get to the point where one side says a number and the other side says the exact same number, you had the two equations, or your two equations were the exact same one. So that means that there are infinitely many solutions, because a solution to the blue, can't spell, infinitely many solutions. And like I was saying, the reason that this is our answer is because if we find a solution to the blue point, it's also going to be a solution to the red point because they're the same line. And that is why we have infinitely many solutions to this system of equations. I have one last example to look at. Now in this example, I'm going to start with my x's again. I always start with my x's because they're first, or whatever the first variable is. And I'm going to look to eliminate those if I can. And I look at them and I see that they're both the same thing. So I can subtract them to eliminate the x's. 7x minus 7x. Again, that puts us at 0x. Then I go to, well, 9y minus 9y. Well, that's 0y equals, and now I'm going to have 3 minus negative 12. 3 minus negative 12, that's 15. Now in this example, notice the left side of this equation is just 0. The right side is 15. That's a little different than the last one. It's similar in the fact that there's no variables in our equation down here. But it's also different because now we have one number, 0, equal to a different number, 15. What does that mean? Well, in this case, this means that our lines are parallel. And if our lines are parallel, they're never going to intersect, which means we have no solution. So if you think back to solving a system of equations by graphing, if we were to graph these two lines, they would never touch because they're parallel. And if they don't touch, we're never going to have an x and a y value that satisfy both of them. Therefore, no solutions, or no solution. And that's going to conclude my lesson on solving a system of equations using elimination.